Hello, so Dr. Conklin did page 25, went over this coordinate proof, and then I'm going to go over page 26. You can see up there, it's way up, there we go. So page 26 has number 2 on it, and last week, toward the end of last week, we did 4 slopes and 4 distances. I have 4 fingers, so I'm going to show you 4 slopes and 4 distances. But today we're going to actually take that and do a complete coordinate proof because everyone's a little bit different. And if you can see here in number, if you look up there at, where is it? There it is, the rectangle. So every shape has a different process. So a rectangle needs certain things to be a rectangle. A rhombus needs certain things to be a rhombus. Parallelogram needs certain things to be a parallelogram, but we're going to be looking at rectangle up there. So if we go back a few pages to page 24 and you look up there at rectangle, what do you need to be a rectangle? You have to have right angles and you have to have opposite sides being parallel and congruent. So let's figure out how to do that. Let's figure out how to find opposite sides being parallel and congruent. If the opposite sides are parallel, that's got to do with slope, right? And if the opposite sides are congruent, that has to do with distance. And the right angles has to do with negative reciprocals. So for example, if I had a slope of -3/5, just an example, and I had a slope of +5/3, that would be perpendicular, right? Because you have negative reciprocals, so you have perpendicular, which means 90, which has something to do with a rectangle. Okay, so let's go back here to number 2, and if you may already have it plotted from last week. If you don't, go ahead and go up there to the top there and plot it. Give you a second to do that. It's at -2, 2, 1, 0, 5, 6, and 2, 8. And it should look like that. Using a straight edge, it should look like a rectangle. But you have to prove it's a rectangle. You can't just say it looks like one. So, like Dr. Conklin said in the last video, if you make this little grid here, you can find all the slopes. So let's find the 4 slopes up there, right above me there. Hope it doesn't fall on me. Let's see if we can do that here. I'm going to get to work. The slope of AB, the slope of BC, the slope of DC along the top up there, and then the slope of AD. Okay, so let's find the slope of AB. From A to B, it's going downhill. We're looking down. So it looks like it's going down 2 and to the right 3. So then if we go up here and we say rise over run, which is good enough to show your work, as long as if you say rise over run, that counts as work. So we said down 2/3 because we counted down 2 and over 3. Then we'll find the slope of BC. And from B to C, if you look, there it is up there, it looks like it's going uphill. So it's going to be up 1, 2, 3, 4, 5, 6/4. Up 6/4. So again, rise over run was 6/4, but don't forget, you can reduce that. You can reduce that to 3 over 2. So now we have a negative 2 over 3 and a 3 over 2. That looks like a negative reciprocal, which means we have a 90-degree angle. So right away I know that this and this meet at 90 because the slopes were negative reciprocals. That's important because we need a 90 to be a rectangle. Okay? All right. Okay, so now we'll look at BC. BC goes up 6 and over, let's see, 4, right? Up 6 and over 4. So BC would be the rise over run would be 6 over 4. And 6 over 4 can be reduced to 3 over 2. So now you notice we have a 2 over 3, and we have or negative 2 over 3, and a 3 over 2, which are negative reciprocals, meaning AB and BC must meet at a 90-degree angle because they have perpendicular slopes, because if you look at those two, they're negative reciprocals. And then we can finish and find the other two. The slope of DC, I'll switch colors here, would be down 2 over 3. Right? Down 2 over 3. So the rise over the run would be down 2 over 3. Okay? And then AD is this last side we haven't done yet, which is up 6, way up there, and over 4. So 6 over 4 again. So the rise over the run was 6 over 4. Again, we have 90-degree angles here and here. Well, I forgot to reduce that. 3 over 2. So we have 90-degree angles again because negative 2 over 3 and positive 3 over 2 are negative reciprocals. So we have 90-degree angles here as well. So we have 4 90-degree angles. And if you look back at page 24, we needed 4 right angles to prove that we had a rectangle. We just did that. So now, what else do we need? 2 sets of parallel sides. If you go back here, opposite sides are parallel. We'll get to this later. But we already know they're parallel because 2 of them are the same. So there's our 2 parallel slopes, and here's our other 2 parallel slopes. So now we've proven that we have 4 right angles, and we also know that we have 2 sets of parallel sides. So the last part is to find out that they're all, or that the left and the right are congruent and the top and the bottom are congruent, because on page 24, we also need them to be congruent, opposite sides. So let's go back and look at the opposite sides. So now we have to do distances. So let's do this again, and we'll find the distance of AB. Okay? And then we'll find the distance of DC, and the distance of BC, and the distance of AD. Now, last week I told you there was a shortcut to doing distance. You can, if you want, and there's nothing wrong with this, using the distance formula, But I told you last week that this is really just a squared plus b squared equals c squared. So it's really just the Pythagorean theorem. So if you wanted to, since you already have the triangle sort of drawn from slope, you could say, well, here's a triangle with a side 6, a side 4. Actually, it's a right triangle, right? There's a right angle up there, up there. And you're just looking for the hypotenuse. So it's 6 squared plus 4 squared equals c squared. So that was AD actually. So it's 6 squared plus 4 squared equals c squared, which is 36 plus 16, which is 52. Then you can take the square root of 52. And if you wanted to break that down, you would say 4 and 13, so 2 radical 13. Now what your prediction, Dr. Conklin mentioned predictions in her video. So what side do you think is also going to be the same distance? Probably this one, right? So here's another triangle. It doesn't matter whether you draw it there or there, because it's still going to have sides of 6 and 4, which is going to basically mean you have the exact same work for this one as you do. Let's try that again. For this one. So AD and BC are both going to be 2 radical 13. AD and BC. Okay, so now the other two, let's try AB. Here you have a side of 2 and a side of 3. So then I go to AB and I say 2 squared plus 3 squared, and that's 4 plus 9, which means that C becomes just radical 13, which can't be broken down any further. So predict again, what other side is going to be that same length? Well, obviously this one. So DC is also going to have a triangle of 2 and 3, which basically means you're going to have exactly the same work here as you did here. So now we have done all the work we need to do, probably more than we needed to do. We found that we had right angles because we had negative reciprocals. We found out that we had two sides that were parallel, another two sides that were parallel. And then we found out we had two sides that were congruent and two other sides that were congruent. So now you can say A, B, C, D is a, now what did they want you to say? It was a rectangle. We've proven it's a rectangle because, did we do all the stuff it said up here? Because opposite sides, look up here, opposite sides are parallel and congruent, and it has 4 right angles. And you proved that with all that work. So because opposite sides are parallel and congruent, and there are 4 90-degree angles, and you have work up there I should say, that shows that you knew how to do that. So 4 slopes, 4 distances, we had the perpendicularness right there, and we had a concluding statement that explains why our work makes sense. So that's a coordinate proof from start to finish, and we'll work on that the rest of the week.